Video tutorial about the Pamela plugin for Grasshopper. Pamela stands for Parametric Membrane Load Analysis. So it's about form finding and designing membranes, tensile architecture projects. The components I have developed are grouped according to their main purpose into the groups up here. Each component has its own icon. And so the first concept I want to explain or to show you is actually the concept of smart components. So I've selected one, I place it here, and you see there's not just one component that is placed or instantiated, there are multiple ones. So for each component, I automatically also add input parameters, input selectors, according to the value. So here's a boolean, or here's a number, an integer number that is asked for. So I add automatically a number slider, and I also do preset the minimum, maximum, and the default value of those input components automatically based on the current data. So here is this component is about selecting an item from a list, and the list is empty, so we don't have anything to select. Let's see how that works. So we create a list of points. I already have some points predefined here. Oops, that's the wrong one. Internalize the data. We add it. We have 11 points, so we can select from 0 to 10. You see here on the left the point that is currently selected. This is a zoomable user interface, so if you want to select more than one point, you can zoom in. You just add more selectors. Now we have 3 points selected. We only see 2 crosses over here. This is because this component here displays as a warning. 3 contains more branches than this component has. So let's just add one. Now we have 3. So each of the 3 points is displayed. We have a list, the 3 points selected, or if you want to get individual access, you can use this one here. First, second one, and the third one. So this is the first concept, smart components. They're grouped. They also have a label here. You can change whatever is written there. And it helps you to identify it when you zoom out. So that greatly improves the usability. Another component is, general purpose component is to define a vector, a direction. I call it a direction. So you see here, we get that blue arrow. So we can set the vector from one point to another. Or let's just set that, anchor point. Let's take that one, that we have it. Okay, it's this one there. This one. Well, this is the origin of the vector, and the length is currently 2. This is the next concept. We have this message box where I usually display useful information about number of objects selected, like here it's the current length, and whatever you're interested or most interested it helps to verify the input data. Or if you want to change the length of that vector, you go in here and you can change that length to 2.6 or to 0.26 or to 26 or whatever. So now we have it changed to 2.6. You probably also want to give it a different label. It's the wind. And if you don't like the position of the label, you can change the position. You can change the text size. We have a preview color, which is currently the blue. You can change that to some different color there. And we have thickness of the arrow. You can also choose here. This doesn't affect the value of the vector. It's just about displaying it that you can better easier see it. Or now, this vector is pointing in from the origin towards the direction of x, but you can rotate it around x, y plane, or you can actually also rotate it this way in towards z direction. 0. If you want to have a vector pointing from here to there, you just set the direction, preset that direction. Yes, use the right point. So this is preset the direction. It's from here to this selected point, but still with length 2.6. And if you use those 2 points, make sure you don't have rotation on, otherwise point somewhere else. But it also can be used for that if you want to have 10 degrees offset or whatever. So this is direction component. Now we have also the vector data component. You can use that input here to show how this one is working. Now here again, count 1, x, y, z. That means we have x, y, and z coordinates or component of that vector selected. Now we have x, y, z. It's currently unitized, so let's get rid of that. Now we actually have 2.6 in length. If you're only interested in, let's say, the z component, turn off x and y, and then you only get the z with 0, 0 here. You could also just grab the z component here. If you want to project that vector to x, y, just enable x and y, disable z, and you get the projection to that plane. There's some possibility to use absolute values or to unitize again. So this is if it's unitized. Text output is actually the same output as what's here in the bottom line. X, Y, you can use this text if you want to automatically label the data somewhere. So that would make sure that in your legend you always know it's only X, Y, or it's only Z that is displayed. Well, that's it. These were the main concepts implemented, smart component groups, and the message balloon here with some of the general purpose components. Thank you for watching.